Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a concept of vortex flow, or generally it used to call as a vortex motion also. So vortex flow or vortex motion is defined as the flow of a fluid along a curved path, or the flow of a rotating mass of fluid is known as vortex flow. Okay, let me tell you again. It is defined as the flow of a fluid along a curved path, or the flow of a rotating mass of a fluid is known as vortex flow. Okay, so this vortex flow actually is to found many cases in the natural. If you take examples of cyclones, so this is some pictures I have taken from the net. So this is an example of cyclone, and similarly this is an example of hurricane. And this is an example of tornado. So these are some example of vortex flow. So why I have shown these pictures to you? Because the vortex flow having a major role in the cyclone or hurricane in the tornado case. Okay. So what is the role of this vortex in these conditions, in the cyclone or hurricane or tornado? When the cyclones are formed, or hurricanes are formed, or tornadoes are formed, to identify what is the structure of the storms, what level of storms it is, and what is the intensity of the storm, to identify that structure or intensity of the storm, this vortex is required to identify that one. Okay, this concept is required to identify the storm structure and intensity. Okay, so many of the examples are there in the vortex flow. So the vortex flow is actually basically two types are there. One is forced flow. One is forced flow vortex. Another one is, you can say, free vortex flow. One is free vortex flow. Another one is forced vortex flow. These are the two types of vortex flow. So forced vortex flow, basically you can see many of the examples are there in the forced vortex flow. Like if you stir a water in a hot basin or any kind of rotation machine, then you can get a forced vortex flow in that. Even apart from that, if you take a vertical cylinder, so here I have taken an example of this. Two cylindrical objects are there. These two vertical cylinders are there. Here shaft is there, you can see. When the shaft is in the normal condition, that means there is no rotation of the shaft in this cylindrical object, and here liquid is there, and this is normal position, that means before rotation. And when the shaft started rotating, you can see while the shaft is rotating, there is a vortex creation is there. Okay, this creation of vortex in the water. Why it is created? Now due to the rotation of the shaft in the liquid. Okay, so due to this vortex formed happened. So this is an example of force vortex flow. Let's discuss one by one about both of the terms. So first let's discuss about the forced vortex flow. Okay, this forced vortex flow actually, here I have taken an example. This is the type of vortex flow in which some external torque is required. Some external torque required to rotate the fluid of mass. Okay, in the definition also I told you that it will be rotate the mass of fluid, or the fluid along a curved path. So here if you see the fluid along a curved path, and here if you see the fluid is going to be rotated, okay, along the mass of fluid is going to be rotated along some external torque here. Okay, so the forced vortex flow is defined as, you can say, some external torque is required to rotate the mass of fluid, and the fluid mass in this type of flow rotates at a constant angular velocity, that is omega. Okay, so the omega is required here to rotate this mass of water with a constant angular velocity. So omega is nothing but here angular velocity, we can mark it. Okay. And that you can see the tangential velocity of any kind of fluid, the tangential velocity of any fluid particles can be calculated from these. Okay. So suppose if you want to calculate the velocity of that particular fluid particle, okay, so this velocity we can calculate by this angular velocity and what is the radius of the fluid particles. So that means the V can be calculated angular velocity into the radius of the fluid particles from the axis of the rotation. Like means this is the axis is there, that at what radius that fluid particle is rotating, or the fluid particle in the rotational mode, how much radius is there. Okay, so by that we can calculate the velocity of the object. So this is about the force vertex flow. Okay, I'll show you some examples of this force vertex flow, and this is one simple example what I have shown you. Okay, and let me show you another one. Yeah, here if you see, there are few examples of this vertex force vertex flow is there. The first example you can see here, there is a jar on this magnetic stirrer. This is a magnetic stirrer, and this is the jar of contents of liquid. Now this is another one, thermocouple is there for to measuring some temperature level. And now if you see, there is a formation of this vertex in this, you know, here when it is started rotating. Okay, when you started rotating by this magnetic stirrer, then there is a vertex formation is there in this. So this is force vertex flow. Similarly, if you take a grinder or a mixer, when you are grinding something in that, if when you rotate this one, then you can see there is a vertex formation, like, you know, this curved path is formation here. Okay, and if you see look deeply, there is a vertex formation also will be there in this. Similarly, here if you just rotate water in a glass with the help of spoon, then also you can see there will be a vertex formation also will be there. Here it is in the normal condition, not in the rotation condition, but when you started rotating this one, then you will get a vertex formation also there. And similarly, when you pour some water or some kind of liquid, okay, in a bottle, here also you can see there is a vertex formation will be there when the water enters to the jar. Okay, so these are some examples of this forced vertex flow. Okay, and there are many examples related to our fluids. So few examples I have given, and some few examples, like, you know, this is the vertical cylinder which contains of liquid rotated with the central axis. This is an example. Again, apart from that also we can say some examples are related, you know, the flow of liquid inside the impeller, the flow of liquid inside the impeller of a centrifugal pump. This is an example. Another example I can say, similarly in turbine case also you can say the flow of water through runner, the flow of water through runner of a turbine. So how many examples? Like these are two examples. Then we can say another one examples, like, you know, preparing juice. Okay, preparing juice in grinder or something you can grind in that, and mixing of particles or some liquids in magnetic stirrer. So many examples actually there. And while pouring the petrol also in the bike, if you see, if you take a 1 liter of petrol in the plastic bottle and you want to pour in the tank, there also vertex formation will be there. So like that, many more examples are there. And here I can say one more, that if you take a bucket of water or glass of water, and you start stirring it by hand. So this is also one force vertex flow example. Now we'll see about the free vertex flow. So this is also similar kind, like, but slightly it is different than the force, because in the forced vertex flow we required some kind of external torque, as I told. Now in the free vertex flow, let me write, in the free vertex flow, there is no external torque is required to rotate the fluid mass. Here, no external torque is required for this. Okay, this is one concept. And second one is, I can say that the liquid in this case of free vertex flow is rotating due to the rotation of imparted to the fluid previously. Like, it means already some kind of force is existing in the liquid, due to that it is flowing. Okay, or some vertex forming in that. Now here I have taken some examples of this free vertex flow. Okay, there you can see this is one example, this is one example, and this is one example of all this free vertex flow. So what do you mean by this already existing some kind of force in that? Okay, because here there is no external torque required. Okay, so how the vertex formation will be there in this? Now due to the gravity which is present in the liquid. Okay, now if you see, there is a sink basin is there, and in that, after pouring some water in the sink, okay, when you close this tap and if you open that basin valve, then you can see here also there is a vertex formation will be there in this, because already there is a gravitational force is acting on that, and due to that the water is going to fall, like, it is going to be enter into the pipe automatically. There is no external torque required for this, or external force is not required to supply this water to the pipe. Similarly, another one is the flow of liquid, okay, in a circular bend of pipe. This is one more, like suppose any circular bend pipe is there, and the flow of liquid in the circular bend pipe, automatically when the flow will be there in this pipe, this water is going to be come inside this. But here, if also here also you can see a kind of vertex formation will be there at this bend of this position. Okay, this is another topic to discuss actually. And you can see there is a whirlpool. There is a whirlpool in the river. If you see in the river, some kind of whirlpool is there, and some holes will be there automatically in that, and there you can see there is a vertex formation also will be there when the liquid is going to inside in that. This is also one kind of tornado formation will be there in this also. And the flow of liquid in the centrifugal pump also. In the centrifugal pump casing, if you see, there also free vertex flow will be worked on that. And this is another example, like two plastic bottles are there. Here one bottle, here another bottle. Now if you keep the water in this bottle, and if you want to transfer this water to one bottle to another bottle, automatically you just pour this, reverse this bottle into the keep in the another bottle, and if you see, when the water is going inside, that must gravity will be work on that, and here again we can see there is a vertex formation happened here, and this vertex formation is coming under the free vertex flow. These are coming under the free vertex flow. There is no external torque is required to conduct these things. And for this also, as we know, there is a relation between the velocity and radius. Velocity and radius in the free vertex flow. Okay, which is often by putting the value of some external torque is, because 0. External torque is here is equal to 0. And or you can say that time rate, the time rate of change of angular momentum, that also the momentum is also must be 0. Previously, if you see, we have some value of that. Okay, the velocity, what we got here, some angular velocity into some radius of that rotation. But here in this case, torque is 0, so you won't get anything in that. So let consider a fluid particle of mass m, okay, and at a radial distance of r. At a radial distance of r, this is of mass, and suppose this is the radial distance, and the distance from the axis of rotation having a tangential velocity v. Okay, and so we can write the angular momentum of this. just a small derivation is there. Angular momentum, we can write mass. We know that momentum equal to mass into velocity. So here also we can write angular momentum mass into velocity. So m into v. And moment of angular momentum, we can write moment of angular momentum equal to, this is the momentum into the radius. Okay, so momentum equal to what we got, angular momentum equal to m into v. So m into v into r. Okay, now what I can write, that time rate of change. Next I can write the time rate of change of angular momentum. The time rate of change of angular momentum, just to derivative of this term, derivative of this moment of angular momentum, derivative of with respect to time. So what we got, mv r. Okay, so for free vertex flow, what do we know, that for free vertex flow we know that this equal to 0, del by del t mv r equal to 0. The time rate of change of angular momentum, that is equal to 0. So we can write this equation equal to 0. Now let's integrate this equation for both side. Okay, integrate this equation from the both side. We can get it what? Now integration of this, we can write only mv r, and integration of this some 0 value, we will get only a constant term will be there here. So we can write mvr equal to constant. Now mass of the fluid, that is also constant value is there. So keep other side. So you can write vr equal to constant by the mass. So finally what will get? Now v to r equal to constant. Okay. So this is the equation of that. Mostly they won't ask this equation to derive, but sometimes they may ask. So you can go through this equation. So this is all about the concept of free vertex flow and the force vertex flow. I hope you understand. If you're having any kind of query regarding this, doubt regarding this, you can give a comment on the comment box. Thank you all.